State the vertical, horizontal, and slant asymptotes of the rational function, or state that they do not exist. The first thing you want to do is take a look at your rational function in fully factored form. In this case, our numerator of x squared minus 4 is a difference of squares, and we can factor as x plus 2 times x minus 2 divided by x plus 3. Now, from this, you might be able to reduce a factor, which actually creates a hole in the graph, and it might also decrease the number of vertical asymptotes you have. In this case, nothing reduces. The numerator equals 0 at x-intercepts. We're not interested in the x-intercepts on this question. The denominator equals 0 gives us the equation of the vertical asymptotes. So the denominator equals 0 gives us x equals -3 is the vertical asymptote. I will shorthand this to VA just for efficiency. All right, so we have the vertical asymptote. Horizontal asymptote. The difference between the horizontal and the slant asymptote cases is dependent upon the degrees of the polynomials. So in this case, the top is degree 2 from the x squared, and the bottom is degree 1 from the x. The horizontal slant asymptote situation, if the degree in the denominator is larger, then y equals 0 is the horizontal asymptote. If the degrees are equal, then the fraction of the leading coefficients, y equals that value, is the horizontal asymptote. Or if the degree in the numerator is larger, then we get a slant asymptote. So we do not get a horizontal asymptote because the degree is larger than the numerator. The other two cases, we would. And for the slant asymptote, we do a division. This could be done with synthetic division in this specific problem. Let me add a placeholder to make the work line up in columns better. The long division always works, so I emphasize long division in finding slant asymptotes. X times x is x squared. We then proceed to distribute that x through to get x squared plus 3x. We then subtract, which I like to notate by drawing a line and changing the signs that were there by putting new signs above the old signs. Equivalently, you could have had just minus in front of all that. And then think through in your head subtraction instead of visualize subtraction. I much prefer to visualize in subtraction. I end up making fewer mistakes. We then drop down the next term, minus 4, and we repeat. X times -3 is -3x. And then we distribute. That is -3x minus 9. We then draw a line and change the signs so we can visualize the subtraction. We have -4 plus 9 is 5. So basically what we have done is we've rewritten the function f of x equal x minus 3 and then plus the remainder of 5 over the original divisor, x plus 3. All this long division does is rewrite the function. Now the remainder, when we let x get very large, goes to 0, making the slant asymptote what's left over. So this part, without the remainder, y equals, that's your slant asymptote. So we have y equals x minus 3. So this completes the question they have asked. State the 3 different types of asymptotes if they exist. All right, I hope this helps.